Hello. In this video, we're going to do an introduction to exponents and tie that into something we might already know how to do, and that is prime factoring. The first thing we want to understand is the anatomy of exponents. So 2 to the power 5, or 2 to the 5, is a power. There are two things we always want to identify when we're working with a power. The first thing is the 2, which is the base. The next thing, which in this case is the 5, is the exponent. When we're representing a power, we could write it out like this. 2 to the power 5 is said to be in exponential form. Of course, we could expand this out, and we could write, instead of 2 to the power 5, we could say 2 times 2 times 2 times 2 times 2. And this is called expanded form. If you're ever unclear about which form to use, I would say fall back on exponential form, because that is a neater or more tidy way to express what you're working through. It also is very useful for some little tricks we're going to learn as we move forward. So somewhere where powers are useful is when we're writing out a number as the product of its prime factors. So let's take this example here. We want to write 2700 as a product of prime factors. So to do this, we can use what's called a factor tree. And to find out what 2700 is as a product of prime factors, we find all the factors that are prime, and we just kind of work through it systematically. So I start by writing the number 2700, and then I say to myself, what is the largest prime number I can think of that 2700 is divisible by? And very quickly we can see it's 5, because it ends in a 0. So 2700 divided by 5 is going to be 540. Now I can divide 540 by 5 again, and that's going to give me 108. And now it's no longer divisible by 5, but 1 plus 0 plus 8 is 9, which is divisible by 3, and therefore 108 is divisible by 3, and that will give me 36. 36 is divisible by 3, and that's going to give me 12. 12 is divisible by 3, and that's going to give me 4, and 4 is divisible by 2. And now we notice that the ending branches on this factor tree are all prime numbers. So we can work back up this tree. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36, 36 times 3 is 108, 108 times 5 is 540, 540 times 5 is 2700. The numbers here represent the prime factorization of 2700. So we can say 2700 is equal to 2 times 2 times 3 times 3 times 3 times 5 times 5. 2 times 2 times 3 times 3 times 3 times 5 times 5. And now we can rewrite this using exponential form. So 2 times 2 is 2 squared, times 3 times 3 times 3 is 3 to the power of 3, or said 3 cubed, times 5, which is 5 squared. And now we've written 2700 out as a product of prime factors, and we used exponential form to make it look a little tidier. And this will also be really useful when we're doing some other manipulations later on. I really want to highlight as we move forward, focus on the vocabulary of the mathematics you're learning. If you get the vocabulary correct, then the questions become a lot easier. Very often students struggle with problems not because they can't do the math, it's because they don't know what the words are asking. I hope this helped.